Hello all, in this video we will work on a problem taken out of a physics qualifying exam from Columbia University from back in the day. And the reason we are doing this is because I have plenty of notes sitting uh, in my office, in my backpad, everywhere. I mean, if you look at my desk right now, it's full of notes that I made, while studying physics and now for the purposes of this channel, etc. So I figured out why not. So I found it very interesting, and there is not much to it except one thing that I will hopefully cover correctly in the video. The solutions are mine. I think they are correct. But if you think something's wrong, let me know in the comments. And I hope this lands on some, I don't know, graduate students' suggestion list. We will see. So let's read the problem. A mass M. So this mass, let me use red. So a mass M, okay, lowercase m, slides down a circularly curved surface on an object with mass capital M, as shown in the diagram below. Mass capital M is free to slide on a frictionless surface. So this surface that I'm pointing at right now with my marker with red color is frictionless, okay. What are the final speeds of the two masses after M, lowercase m, separates from uppercase M? So let's see. Let me erase the things that my writing there. So let's try to think of what's going on here. So actually, let's create some space. Actually, I will need to use white with this blackboard. That's another reason I'm making this video. I want to test other filming ideas with my iPad. So they now offer this whiteboard or blackboard option that I'm using today. So okay, so let's draw the situation again. So this is the big block, I guess. Okay, and it has a curved surface. Okay, which is the quarter of a circle, pretty much. Okay, so I'm gonna draw that. Okay, so this is the circle. So this distance is r, and this distance is also r. And okay, let's try to think of the forces involved here. So first of all, on the capital M mass. So the only force is the reaction force, right? So if, okay, the center of mass is not going to be, it's going to be complicated to find the center of mass. Actually, this is a problem, another interesting problem you can work on to find the center of mass of this block, I guess. If you can think about it as a lamina and find it. Anyway, that's not the point of the video. So let's say that, let's write down the forces. Let's say that the center of mass is there at the cross. So there will be reaction force from the floor and the gravitational force from, the gravity, the weight of the block, right? But there is another block, okay? This, I'm gonna draw it in a random position, okay? So this is the block, the smaller block, M, okay? So what kind of forces are exerted on that? So there is the reaction force, okay, from the circular surface, okay, N, but then the lowercase mass m also pushes, I think this is the correct way to treat it. I'm not 100% sure, so if I made a mistake, let me know in the comments, but also the lowercase m mass is pushing the bigger block M with the same force, okay? So there is a reaction force on capital M, okay? So on the big block from M, okay? And also, of course, on the smaller mass, you also have its weight, M times G, okay? The main point I want to make here is that if you analyze these reaction forces, so these reaction forces N, and maybe we can write it N prime. So N is equal to N prime. So this is a Newton's, okay, third law pair, I think. So because I had a really hard time understanding why momentum is conserved, this is what I will come to in a moment. So to understand it, I had to draw the forces and everything. So in the vertical direction, you don't really have a conservation of momentum, okay, because all those forces are not necessarily equal, but there are no external forces acting on the x direction, okay, so that's the key here, because if n and n prime are equal, then you can analyze them into a vertical direction that we don't care about, okay? We only care about the horizontal direction. And in the horizontal direction, if you have, okay, the x component of n and the x component of x prime are exactly equal and opposite, okay? So nx is nx prime, so no force in, no external force, okay? I mean, that's the key here. So no external, no external force, okay, force in the x direction, okay? And with no external force in the x direction, let me switch to white. So with no external force in the x direction, okay, momentum is conserved in the x direction. Okay, so let me draw the picture again. So we have this weird object with the circular part. Okay, so that's your M, capital M. Okay, and this is the small block. So I'm gonna draw it at the lowest point there. Okay, and you will see why in a moment. Okay, so at the lowest point then, this guy is gonna have a velocity, let's call it what should we call it, v lowercase m, okay? So this guy is gonna have a velocity to the right, and the bigger mass, let's use white, is gonna have a velocity v subscript capital M to the left, okay? And because there are no external forces in the linear direction, in the x direction, the momentum of the lower block, the lowercase m, the small block, is equal to the momentum of the big block. I hope this makes sense. So in other words, m times vm is going to be m capital M v capital subscript capital M, okay? So that's the first thing. And we can also use conservation of momentum between, of energy, okay? Between, and again, we can use conservation of energy because the forces involved in this problem do no work, because so you have frictionless surfaces, okay? So the first relationship is this one, and the second relationship is that if we use conservation of energy between point 1 and point 2, we immediately see that lowercase m times g times r, which is the gravitational potential energy of the smaller block, is equal to 1/2. So we take so at position at point 1, at point 2, we take the gravitational potential energy, let's call it GP. So we take GP to be 0 there, okay? So where was I? Okay, so mg times r, because this distance is r, is equal to 1/2 lowercase m v m squared plus 1/2 large m, I mean capital M, times v m squared. Okay, so we have two equations, two unknowns. So we pretty much solved it, but let's keep working to find the actual expressions for the velocities. So mgr is equal to 1/2 m and then v lowercase m squared plus 1/2 and then capital M, and then we will substitute the v subscript capital M with with this expression there. Okay, so this becomes equal, let me focus, m squared over m squared times vm squared. So we have this cancellation. Okay, so we can also cancel this, right? So this can gets cancelled. Maybe I should use the same color so it's obvious. So we choose color. Let's do red. So this, and that get cancelled. Okay. So we have Vm squared times 1. Oops, forgot the 1. 1 plus m over capital M is equal to g times r. Okay. Vm squared over 2, excuse me. Okay. Which means that v lowercase m becomes 2 times g times r over 1 plus m over capital M. Okay, and all this is under a square root. Okay, and now that we found that, it's easy to find the velocity of the big mass. Okay, which is going to be equal to m over m times this expression. Okay, 1 plus m over m. Okay, and as it's natural, okay, Vm is actually much larger than Vm. Okay, and is there a way to see this? I mean, if we take the limit, so if m goes to infinity, okay, so if we are talking about a really heavy block m, and again the big block is this one, okay, if it's really heavy, okay, what's going to happen? Vm is going to be equal to the square root of 2gr, which is the familiar relationship you get from free fall, pretty much, right? Am I right? mgh should be 1/2 mv squared. Yeah. Okay, so that's the free fall. Excuse me, I had to, I mean, we are humans, we make mistakes, guys. Okay, so yes, we get that. And then for the big block, v capital M is going to be, you will have 1 over infinity there, so that's 0 multiplying something, so 0. Okay, so it's gonna be movable, okay, which makes sense, I hope. So this is the video, guys, short this time. For the regular viewers of my channel, I do long videos where I walk people over the solutions to A-level tests from England. But I said it multiple times in this channel. The channel is meant to be my physics playground / coding playground. And gradually, I want people to come over and see what I'm doing. And if there are other interested people, we can do something with physics. I don't know. But okay, I mean, this is one of the first attempts to have content different from physics exams from England. But I'm not going to give up on that either. So I'm going to keep uploading high school physics material. But this is from graduate school, guys. So it's more advanced. I hope you enjoy it. Actually, high school students can understand this as well. I mean, it's not that advanced, but yeah, I mean, it's difficult to imagine someone giving a high school student this problem. Okay, so this is the video, guys. Please like and subscribe. Do let me know what you think about using this whiteboard. Okay, I kind of like it. I never used it before, and it allows to film in a vertical, I mean, in a landscape mode. Okay, so I don't know if I will adapt this. I will try to see if it can be adapted to my A-level walkthroughs. We'll see. No promises. And yeah, this is it. This is the video. I have links in the description to my Buy Me a Coffee account and also my PayPal account. I mean, the channel is still not viable, venture, but it's fun. So if at some point people want to help with this effort, I will be more than glad to receive that help. So anyway, guys, see you in the next video. Bye.